5G is a long process. 5G is not ready, and it's something in evolution. It's going to be the connectivity for the 20s, as 6G will be for the 30s. And I think Europeans have to become aware of the role they have to play in this, in the making of 4G and 5G and 6G.
Despite of Hispasat is a medium-sized operator, we are always trying to be in the state of the art of the technology, and we promote and boost the innovation of to the services in order to be able to provide the best fit solution to our clients. This, as you commented, an example is Amazon Nexus. This is a new generation of satellite where we embark the state of the art of the technology that provides flexibility, and it could be in a future become one of the first satellite integrated in the 5G network. Related with 5G, satellite is needed to ensure connectivity in these areas and remote areas and mobility environments where the terrestrial network are not feasible. Within Hispasat 5G strategy, we are performing trials and pilots to test performance and work in the future use cases, and also detect the areas where we have to work. Some example of these future use cases and projects are the 5G Met, for instance, that is a European European project where we provide added value services in mobility and remote areas, in trains and motorways. We are also working in a new use cases that is the monitoring of critical infrastructures like high power electrical lines through autonomous drones. We have also the Darwin that I'm completely sure that Rodrigo will comment afterwards. Also, we are working in a use case that is called enhanced 5G backhauling with our colleagues of Nearby Computing, where we are creating 5G cell standalone core network, including technology like edge computing that improves the user experience running some application on local. So this is much more or less the summary of the use cases that we are testing right now.
Hein, can you start by telling our audience what kind of company Nearby is, and why have you chosen to partner with a satellite operator?
Thanks, Arti. So Nearby is a edge orchestration company. So we basically based out of Barcelona, and we deliver edge computing and end-to-end management and automation solutions through our orchestration platform. For example, gaming as a service, content delivery, being able to run local computer vision type applications like cameras, and autonomous drones that Jose Luis was talking about. That's something that you could bring the latency down by running edge computing in an edge node, and being able to actually manage that with your backhauling being provided by the satellite provider.
Some people already know we are developing use case of hybrid connectivity. So we really leveraging the combination of mobile and satellite. And our specific focus is on mobility services. We work with great partners in Hispasat, supported us a lot on our journey in the satellite segment. As you put in the beginning, we originally an investment from Telefonica in the UK, where they saw the opportunity to innovate on bringing together these two worlds, terrestrial networks and satellite networks. And Project Darwin was born from an investment.
The release 17 is confirmed to be completed in March, and this package is going to enable the 5G system to support backhaul over legacy networks like DVB based, featuring static latency and static bandwidth, but also it's going to allow to deploy 3GPP defined access technologies based on either the 5G new radio protocol or the 4G narrowband IoT and EMTC radio protocols, more for IoT. Both technologies are enhanced with some features to address the latency, the beams, which are different than radio cells in the mobile systems, and they are based on transparent payload satellite.
Satellite has a key role to play. When I mention what I intend to be impressive speeds, I also mention center of Madrid, Barcelona, cities around the world. The possibilities of satellite is bringing these 100, 200 megabit per second everywhere, not even to a high percentage or eventually 100% population coverage, but area coverage. And that opens a whole range of opportunities. We're witnessing a situation now where we have the type of evolution of standards and technical capabilities that Alain described, as we have to encompass that with an evolution of business models. We have to leave behind or add on to the legacy service, telecoms, content distribution, which is still live on, thanks to people like Darwin, people with like the edge computing. These people have to reinvent themselves, and we had to add innovative backhaul, area coverage, and especially one area where exciting news are happening now is IoT. IoT, where we have the prospect of having coverage IoT on a whole range of gantry, difficult to cover like spin. We're talking here about emergency situation, logistics, everywhere where the IoT is going to play a big role now. And I think the evolution that we're witnessing is all about economies of scale. I think satellite industry have been cornered on niche applications where the volume lagged behind what was required by semiconductor vendors, for example. And we're witnessing how important semiconductor supply chains are. So now the satellite industry has the opportunity to profit from the huge supply chain and economies of scale of the mobile industry, from chips to RF to digital to AI, edge, you name it. Now you have the whole range and portfolio of capabilities at the long time, the exclusive use of mobile, which can be used in satellite. And that's a key game changer.
3GPP is the entity that is the responsible to create a new 5G standards. 5G is the new network paradigm, is the network of networks. And therefore, I think it's needed to be sure that the satellite is integrated in this new paradigm. All the future of the communications always goes to standardization and massive technology. And whether we like or not, the satellite will be involved in that trend. So it's very important that satellite operators and manufacturers like Thales, that is quite active, contribute to the standardization and be ready to the evolution of 5G and even 6G. If we leave the standardization to process to terrestrial entities only, we are not going to ensure the main principle of the 5G, that is the integration of the different networks in one network.
As well as the user equipment. And we have to make sure that the performance that are being specified are relevant, feasible, and not costly so that we can we have a viable system, end-to-end system. So this is what it is about. And we are in this discussion and we have seen quite an increase in participation in that particular discussion, because we have managed to mobilize a number of people. But of course, we really need to be very careful and have enough critical mass to make sure that our interests are being respected.
Of course, it's important to understand that one of the challenges is the connectivity. Lots of areas are not covered by any type of connectivity. There's certain areas in the map where there's no coverage of any kind, whether it's LTE, 5G, even older technology. So what we're saying is, right, using satellite backhaul, you can create little islands of connectivity by putting down an edge node, using a backhaul, having a central control plane. So firstly, you can extend the connectivity from the terrestrial operators by using satellite backhaul, and that's using the existing type of architecture. And it's important to note here that you can do that even using LTE and 4G. This doesn't have to be 5G right out of the box, because there's certain areas where there's no adoption of 5G, or there's certain regulation challenges, and we understand that's a completely separate problem that's being solved. But it is also the potential that satellite can be the gateway to get people onto 5G. So the idea being is that you're rolling out all technologies, so you can start going into what we call non-standalone, where you run a hybrid 5G and LTE architecture, and then you can go into 5G. So it's a nice progression to be able, and this is just talking about the connectivity. The satellite backhaul provides the connectivity. Now, what makes this enticing is that the edge computing provides that extra value-add services. So again, let's use a scenario of a very remote site where you have a customer that has, let's say you've got somebody that's sitting in a remote village and maybe a mine somewhere in Africa, and you want to start providing specific services to them, so like content delivery networks, like community networks. We're sitting in the middle of a pandemic, so you might want to give them health advice and health warnings. This is a methodology that you can use the satellite backhaul to provide those services. You can maybe give them some, specific services around communication on site. You can provide them the 5G telephone connectivity so that they can be in contact with the rest of the world. And this is just using the existing architecture.
So from our perspective, we don't really deploy 5G services. We leverage 5G and satellites to provide services to end users, and in our case, the end users are vehicles, fleets of vehicles. So we do have 5G deployments, local 5G deployments at our labs, which we use for development and testing purposes. But otherwise, we are not directly involved in deploying 5G. But 5G give us excellent services. So we like to use 5G. We would like to have it more broadly deployed. And we know that unfortunately 5G and 4G is not available everywhere. So if you look at the UK, the latest reports from Ofcom indicate that in aggregate from all mobile operators, there is still 80% of geographic areas that don't have mobile coverage or data services, are either not available or of not good quality. But the use cases that we target, they need 100% coverage. So these are vehicles going through all sorts of routes. So if we're talking about a healthcare service, it has to go to the most remote locations, and it has to enjoy a consistent quality of service. So that's what we are trying to build. We are trying to reconcile satellite connectivity with 5G connectivity to be able to provide these great services 100% of the time.
The satellite ecosystem see the value of 3GPP standard being adopted in the satellite ecosystem, because it's going to be a way to first create a worldwide market for terminals and thanks to the economy of scale, to drive the cost down. Because we all know that today the SATCOM market is completely fragmented. It's fragmented in different systems, each having its own ecosystem, each having its specific terminal vendor, chipset vendor, and so on, which cannot create the economy of scale which is needed to drive the cost down.
I think it's the job of the satellite industry to remind people that they have the big asset of area coverage, very respectful area speeds of 100 to 100 megabits per second. And 5G could be also the opportunity to remind them that reliability is a big thing, is a big criteria for performance. And satellite is going to be ideally suited to provide this.
That's my opinion, and I think it's something that we are pushing. It's just satellite will be the complement to the terrestrial network to provide this coverage in remote areas, in mobility environments, also in emergency scenarios. And will be the complement of the terrestrial network to ensure the 100% of the territory coverage.